Good evening. I'm talking a little bit tonight about biofuels. We have quite a few biofuels that we're using in our nation and world today. And we like to think of biofuels as being green and environmentally friendly, etc., etc. The problem is, this isn't always as true as we might like to think. The problem with some biofuels is they wind up being essentially a way to recycle fossil fuels. For instance, for a lot of these biofuels, you need to burn some sort of other energy like gas or diesel, petroleum-based gas or diesel, to, in effect, produce more gas or diesel. Another problem with biofuels today is they often take up valuable resources, especially like space, for instance, for growing other food crops for ourselves and animals. One more problem with many biofuels that we have restricted though to biomass, which is a form of biofuel. Essentially what it is organic matter, such as like stalks or grass, that you harvest and usually like burn or gasify to produce steam or some form of other energy. Anyhow, the problem with biomass is that when you remove it, it often removes a lot of organic matter from your soil that you need to produce your crop the next year, the next season. Now, with biofuels that we have today, one of the biggest is corn ethanol. Now, corn ethanol, according to the Food and Ag Policy Research Institute of Missouri there, is grown on about 90 million acres and can produce about 400 some gallons per acre of ethanol, theoretically. Now the problem with corn ethanol is, was I kind of stated, basically it takes up a lot of resources that we need elsewhere. We need it for food and for ourselves and animals, for our cattle, etc. Such as the case with soybeans, which is used to produce biodiesel as well. Soybeans, you can get about 65 gallons per acre, which isn't too much, and we have about 70 million acres. Now, like I said, it's the same thing. When we use that to produce biodiesel, we're taking resources that we could use to feed ourselves and animals. Now, on the biomass side, currently we have a couple of things. Corn stover, which is essentially corn stalks left over from harvesting grain, as well as wheat straw. As I stated, removing these, and according to some research that was done using USDA statistics, we can expect to get possibly about 150 million dry ton per year, and that is leaving enough organic matter on our fields, as it were, to control erosion and other things. However, like I said, taking these sources of biomass removes organic matter that provides nutrients for the next year's crop. Now, on the other side, we have some possibilities, some things that have been worked on that haven't really been developed yet, some sources that really show some pretty good potential. One of the biggest ones is algae. According to the the University of California, San Diego, some research they did, algae could theoretically be grown on about 45 million acres in the US. And the neat thing is, we could expect to get somewhere in the neighborhood of 3,000 gallons of oil, kind of like a biodiesel basically, per acre. Now the cool thing about algae is that it works great for purifying water and removing excess nutrients, as well as removing carbon too. Often you'll see algae in things like waste treatment facilities or something like that, which is a pretty good use for it. The unfortunate part about algae is that the majority of its weight is actually, the percentage is actually water. So it is hard to dry and then actually extract the oil. Now on the biomass side, a couple alternatives that we have are cattails. Now cattails we see all over the place, and according to some research, again done using USDA statistics, we could expect to get about 288 million dry tons. Again, cattails do an awesome job purifying our water. They remove excess nutrients from the water, and then essentially when they die, they put it back into the water. Now if we could harvest that, we could use that to purify water in, like I said, waste treatment plants, etc. Also, we have a couple of options using grasses, a couple of tall grasses such as switchgrass or miscanthus. These we could expect to get about 260 million dry tons. And again, this would be using land that's same with cattails and algae. This would be using land that is marginal. It couldn't support crops, or simply the structure, the amount of moisture that the soil has in it can't support any kind of crop. So you're basically using land that isn't and couldn't be used for anything else to produce an energy source. And this is also not including lands set aside for wetlands recovery, other environmental programs. I think it's important to explore these options to make sure that we're not wasting resources, our natural resources on one hand, and then just ignoring other sources that we may have, and thereby essentially abusing our stewardship. I think we as citizens need to push for more research, to not just be satisfied with the status quo, but to always be looking for something better than what we already have. And I think also it may not be a bad idea to just go look in your own backyard, in your own outside your own door, for some ideas, for some alternatives to the energy that you're already using.